Today I'm going to share you our journey to Cloud Foundry at our university. It's called Zhejiang University. I have a map here, so I guess most of you don't know where it is. So it's in the eastern part of China. There are 9 professors and over 100 students in our research lab. We started working on Cloud Foundry like 2 years ago. In the beginning, we did a survey of most of the open source projects that are related to cloud computing. And in the IS layer, we looked into open source projects such as Eucalyptus, Convert, OpenStack, and CloudStack. We chose CloudStack because of its rich functionality, because of its nice user interface, and it looked more stable to us. So we chose CloudStack. And on the PaaS layer, we looked into Cloud Foundry and OpenShift. Cloud Foundry at that time had a much more active user group, and it had better documentation. We waited for like 2 months for OpenShift to finish their installation document, but they didn't so we chose Cloud Foundry over OpenShift. We have been doing this, so since then, we never looked back. We just go with Cloud Foundry. Since then, we have been extending and improving Cloud Foundry in various ways. Firstly, we built the CPI for CloudStack. We chose CloudStack and Cloud Foundry as our research platform, but it takes a very long time to deploy Cloud Foundry on CloudStack, even with the help of Chef. So to save time, we built the CPI. Now with Bosch and the CloudStack CPI, we can deploy Cloud Foundry in like 3 hours. So we don't have to wait for days or even weeks. I'll tell you more about how we build the CPI later. The second thing that we built is the NAS cluster. The NAS server in Cloud Foundry version 1 is a well-known single-point failure. So we developed the NAS cluster. Our NAS cluster is based on the NAS server version 0.5. The NAS server version 0.5 already has the clustering capability, but the clients need to know that there are multiple NAS servers. So we need to modify the NAS client. So we don't want to do that. There are a lot of NAS client over the different components of Cloud Foundry. So we set up an HA proxy in front of the NAS server version 0.5. So now the NAS clients only talk to the HA proxy. So they don't have to know about how many NAS servers there are in the cluster. And with the help of HA proxy, we can add more NAS server to the NAS cluster on the fly. We don't have to reboot anything. We added more services to Cloud Foundry. Now we have Hadoop as a service, Jasper reporting as a service, and Mill as a service, and Cassandra as a service. We added all those. Based on the extensible architecture of Cloud Foundry, it is relatively easy to add a middleware as a service. The tricky one here is Hadoop as a service, because we made the Hadoop service an on-demand service. It usually takes many virtual machines to set up a Hadoop cluster. So if you're not running any data analysis tasks, you may want to destroy those virtual machines and reuse those resources for some other purposes. Also, based on the amount of data you want to process, you sometimes want a big Hadoop cluster and sometimes you want a small cluster. So we made a release of Hadoop. So with Bosch and the Hadoop release, we can dynamically deploy and undeploy a Hadoop cluster on the fly of any size you want. Also, about the Cassandra service, we're trying to improve it now. So currently, the Cassandra service we have is just like any other service we have in Cloud Foundry version 1. That is, it is only a single node. It's not clustering. What we are trying to do is to improve the Cassandra service so that we can just scale the Cassandra service as we can do with applications. So it's very easy to scale an application in Cloud Foundry. Just move the slide. But it's not possible with services. So what we are trying to do is that we are making Cassandra a release. So with the help of Bosch, we can scale a Cassandra very easily. Okay, this is another thing we are doing now. We are trying to make sure that Cassandra, that Cloud Foundry is ready for production. It's not that it's not, it's just we have to make sure. So we did all kinds of testing, functional testing, stress testing, and destructive testing. As a result of those testing, we found that the performance of the router in version 1 of Cloud Foundry is not very satisfactory. So we replaced that with the Go router. Another thing that we are doing now is that we are trying to make the deployment process of Cloud Foundry aware of the underlying topology. Right now, currently, when we deploy Cloud Foundry with BOSH, the BOSH does not make use of the underlying topology. So it is possible that, that BOSH will deploy all the routers or all the DEAs in one single host. And if there's a problem with the host, we may lose all the routers or all the DEAs. So what we are, in order to deal with this problem, what we are trying to do now is only manual. So we are manually moving around those virtual machines so that the routers and the DEAs don't end up in the same host. But we are also trying to improve that so that this can be automatic. This is and this figure shows the major components of the CloudStack CPI. To deploy a Cloud Foundry on CloudStack, the BOSH will first call the CPI to create the virtual machines and set up the storage and network configuration. Then the BOSH will forward those calls to the fork. Fork here is a library that tries to provide a unified interface to multiple infrastructure platforms. Then fork will call the API that's provided by CloudStack, and CloudStack is the one that's actually managing those virtual resources. So to build the CPI for CloudStack, we did these. We implemented the 10 processes that's specified by the CPI interface. Also, we added seven APIs to fork because fork is not designed to build CPIs. So it cannot use the advanced network feature provided by CloudStack, and we happen to need those features to configure the network for virtual machines. In total, the CPI is responsible for configuring over 200 options of CloudStack. Yeah, and it's a Stemcell. Stemcell is the virtual machine template that BOSH used to create to deploy a Cloud Foundry. It takes 6 stages to build a Stemcell, and these 6 stages can be further divided into 28 steps. To make the Stemcell compatible with CloudStack, we modified 3 of those stages. And this slide shows some of the details of what we modified in those 3 stages. It's about setting up the security, network, and the storage of virtual machines in a way that's very specific to CloudStack. And here are some screenshots. The first figure, oh, it's very small. The first figure shows all the virtual machines that make up Cloud Foundry that's already deployed on CloudStack. This figure shows the 8 virtual machines that make up the BOSH cluster itself. And these virtual machines are deployed by microBOSH. And this shows the information about the microBOSH we have made specifically for CloudStack. And this is the administration user interface of CloudStack. And here we can see all the virtual machines that has been created by BOSH during the process of deploying Cloud Foundry. And this image shows that the dashboard works. We have uploaded the source code of the CloudStack CPI to GitHub, so if you're interested, please help us test it. That's all. Thank you.